on scripting. In this video, we introduce the Unity scripting system and create our first script. We briefly introduce scripting and then dive straight in, heads first. We open the Unity manual, user guide, asset import and creation, scripting. You can access it online or offline. Unity supports scripting to define custom behavior and actions that need to occur in our interactive project. Games and interactive applications require several scripts. Through scripts, you can transform objects, react on clicking, run animations, or load new scenes. Scripts are assets, text files, with code that gets compiled into your game. You drag scripts onto objects to add behavior and set the script's variables to customize it for your scene. Unity supports different scripting languages: C#, JavaScript, and Boo. Most tutorials use JavaScript to target people with a background in web development. But we opt for C# as it resembles more to C++ and Java and adheres better to strong typing and object-oriented programming styles. But you can mix and match them both in your projects. Right now, when you added the character prefabs, you already used scripts. They added a custom behavior such as reacting on keyboard presses and moving the mouse. Select any script asset to see a preview of the code in the inspector. We aim to create a few reusable scripts in this video tutorial series. The ideal script is short, has a clear purpose, and can be used without further editing. Furthermore, scripts usually use public variables to allow you to change their behavior without requiring code changes. From the Assets menu, we can create a new C# script. You should immediately give it an appropriate name. Type rotate object. To assign the script, drag it on top of a game object in the scene. If you open the inspector, you see that a new script component is attached to the object, with the script's name rotate object. The name of the component is slightly rephrased for better readability. So far, Unity created a default script that effectively does nothing at all. If you press play now, you will not notice any difference. We will have to write the code to tell Unity what we want to occur. In this video lesson, we learned about the Unity scripting system and generated a default script that does absolutely nothing at this moment. In the next video, we will write a usable script to open a door when the player gets close enough. This is the second video of section 6 on scripting. In this video, we'll edit the script we created in the previous video, as that simply did nothing. Inside Unity, you get a preview of the script in the inspector, but you can't edit it there. Luckily, Unity includes a complete scripting editor called MonoDevelop when you installed Unity. While it is possible to use another editor, we will stick with the default one. To open MonoDevelop, double-click the freshly created script in Unity Assets tab, and MonoDevelop will be automatically launched. The software behaves the same on Windows and OS X. MonoDevelop is a so-called Integrated Development Environment, or IDE. You can edit the code, use automatic completion, syntax coloring, and even run and debug your code. On the left, you see a project solution structure, with all scripts and a whole set of additional folders that are used in the background to translate the script code into the compiled version that Unity runs. We mainly focus on the central editor view, where multiple scripts can be opened, each in a different tab. The tab displays the name of the script. Let's first inspect the default script. The first two lines load the libraries or assemblies from Unity and from Mono. Mono is an open source .NET framework which powers the Unity scripting system. You get the definition of your main class, which needs to have the same name as your script file. This class derives or inherits from Mono behavior. And then we have two empty default methods. They are preceded by a comment line after two backslashes that explains what these functions do. Start is called once when this object is first created, usually when you press play. Update is called continuously upon every frame refresh. Here you write code that needs to react on what happens in the scene. To illustrate this, we will write a simple log message to the console in both functions. Inside start, write debug.log, open the brackets, open the parentheses, we have started, dot, close the parentheses, close the brackets, and semicolon. And in the update, write debug log update is called. Save the script in MonoDevelop and switch back to Unity. If you have no syntax errors, Unity will automatically parse and compile the code and make it available in your project. Press play and watch what happens in the console tab. You should see a single "We have started" message and a whole stream of update messages. If you activate the collapse option, repeated messages are only displayed once, which is useful for this update message. If you write an error, Unity will complain in the console. Switch back to MonoDevelop and write a stupid error in the start method. For instance, change debug into debuggy and save the file. If you now come back into Unity, you get an error. Double-click on the error in the console and Unity steers you back to the place in your code where the error was first found. In this video lesson, we edited our first script in MonoDevelop and tested it in Unity. We also learned how Unity helps us getting back into the code when errors are discovered. In the next video, we will create an actual usable script that rotates a door. This is the third video of section 6 on scripting. In this video, we create a simple script that rotates a door when our player gets close enough. We will show a simple rotating door setup with a hinge and a trigger. Then we write code that reacts at the right moment to turn our door. Finally, we attach a script to the correct objects. It is essential with scripting that things happen at the right time or event. Our script will use the integrated collision or trigger system of Unity. Collisions occur when objects that have a collider bump against other colliding objects. Remember that we needed colliders initially to not fall through the floor of our model. This is the same system. Triggers also use the colliders, but they don't obstruct other objects. They simply register when a collider enters and leaves its volume. Our setup is very similar to the setup from the animation video. An empty hinge game object with a cube for the door attached at the right position. When you turn the hinge, the door follows. Open our rotate object script in MonoDevelop by double-clicking it in the Assets tab. Remove the debug statements from the previous video and write a new statement in the Start section. Type this dot transform dot rotate with a capital R, open the brackets. At the moment you type the bracket, a pop-up appears that shows hints at a possible variance of this method. We'll add 0, 90, 0, close the brackets, and end with a semicolon. Save the scripts when you are sure that there are no syntax errors and switch back to Unity. Attach this updated version of the rotate object script to the hinge game object in the scene. Press play and see if the door opens when the script starts. Check the inspector. That's fine, but we can do better. The door opening should happen only when our player gets close enough. So, add the third-person character we saw earlier. Now also add a new cube. Mark it as trigger in its box collider component and disable the renderer so it becomes invisible. Go back to our script and add a new method that gets called automatically when a trigger event occurs. Void space on trigger enter, open the brackets, and as a parameter, class of the type collider, and this name other. Close the brackets and then open the curly bracket. This replaces the previous call to the rotate command, which was placed in the start method. Add an additional method called onTriggerExit with the same parameter. And add the same code but now with a negative angle minus 90 degrees around the y-axis. Save and test. Notice that it doesn't work correctly. The trigger event needs to be captured by the trigger box, whereas the rotations should occur on the hinge object. So remove the script from the hinge and add it to the trigger. Now open the script again and add a public variable to set on which object the rotation should occur. By adding a public variable, it becomes editable by the user in the inspector. It also allows you to reuse the same script on other objects with different values for this variable. Make the variable public of the class game object and as a name target. Replace this in the code with target in our script. This variable can contain any game object. It can be a cube, camera, a light, or a model. So any object in the scene is acceptable as a parameter for target. Now save the script, switch back to Unity. We have to drag the hinge object onto the target variable field, so the script will act on the right object. Press play to test our setup again. Now, whenever our player enters the trigger box, the hinge rotates 90 degrees and the door, which is attached, will open. Hooray! Our first actual script is running. Congratulate yourself and then understand that this is only the beginning. There are multiple improvements that could be made, smoothing out rotation, reacting only on the player and not on other objects, but this suffices for this lesson. In this video lesson, we set up a door that automatically opens when the player gets close enough, using a trigger event. In the next video, we'll look at how we can switch materials and learn about using a list of objects. This is the fourth video of section 6 on scripting. In this video, we set up a more advanced script that allows you to switch a material while running the game. This requires us to learn 3 new techniques: working with the list of objects, changing a material at runtime, and reacting on keyboard presses. So switch back to Unity. Our basic setup is simply one cube, one light to see something, and a few materials prepared in the assets folder. Add the new C# script and call it switch materials. Double-click it to open MonoDevelop, and we are ready to start. First thing we need is a list for all possible materials, by defining a public variable as an array of materials. Arrays can contain several objects or values and are easy and fast to step through. Write public, then the class material with 2 square brackets, and as a name materials, which creates an empty array. Save the script and switch over to Unity. Drag the script onto the cube object. When the script is compiled, a new variable called materials is displayed as an empty list in the inspector. You can now drag materials onto this variable and they will be added to the list, which expands automatically. But since our script does nothing at the moment, we have to return to MonoDevelop. We want to do something whenever we press the M on the keyboard. Within the update method, write if, open brackets, input dot get key up, open the brackets, key code dot M. Notice that MonoDevelop displays all possible options when you type the dot. This is called auto-completion and helps you when coding. Close the brackets twice and then open the curly brackets. This method will be true at the moment we press and release the M button, indicated as the keycode.m value. The renderer component is where the list of materials for an object is stored. We can access that component in our code. Write this dot renderer dot material and set it equal to materials with square brackets 0. This sets the main material of the object to be the first material from our list, which is indicated by an index 0. Like most programming languages, arrays in Unity start counting at index 0 instead of 1, so be careful. Save the script and press play. Whenever we press M, the cube switches to use the first material in the list. Almost there. We'd like to switch to the next available material with each additional key press, so go back to your script in MonoDevelop. We'll maintain a variable to remember which material from the list we have set. We'll use an int, which is short for an integer, which allows only discrete positive or negative numbers without a fractional part. Write private int index at the beginning of our class definition and initiate it to 0 in the start method. Index equals 0. Since this variable is set to private, it will not show up in the inspector and is only used internally in the script. In the update method, we use the index variable. This .render.material equals materials, but instead of 0, we now use index. And finally, increase the index by 1. To ensure that we don't get past the end of the list, which would generate an error, also use the modulo operator. The modulo gives a remainder after we divide by the given number. And use the modulo operator with the length of the array. So we fall back to the first index after the last one. Index equals index plus 1 between brackets, then the modulo operator, the percentage sign, with the length of the array, which is indicated by materials variable dot length. Now save the script, go back to Unity and press play. Click the M button a few times to see that we shift through all materials in the list and that we skip to the first one after we arrived at the last material. Congratulations! Your second fully functional script. In this video lesson, we set up a script to toggle materials for an object. We learned about using an array to keep a list of objects. We reacted on a key press, and we used some math to loop through our list using a private index variable and the modulo operator. In the next video, we will refine this script with a small user interface, an on-screen button. This is the 5th video of section 6 on scripting. In this video, we expand our material switcher from last video and add a small, simple user interface to it. Graphical user interfaces, or GUIs, are very important in real-time applications. They are easier for an end user, and they work also on mobile platforms with touchscreens, where keyboard shortcuts are non-existent. Unity has a GUI class and a dedicated onGUI method, where we can set up our user interface. As we will make this improvement in our previous script, switch back to MonoDevelop and the switch material script. First, add the GUI event, void onGUI. Open and close the brackets and open the curly bracket. Be sure to use the correct capitalization, or the method will not be recognized by Unity. Within the onGUI method, we can use the methods in the GUI class to add user interface elements. In this example, we use the button method. Write GUI.button and open the brackets. As a first argument, we need a rectangle to define the position and size of the button. Let's create an instance of the rect class. New rect and open the brackets. We now have to add 4 float numbers. Horizontal position, vertical position, horizontal size, and vertical size. Let's use 10, 10, 120, and 20. Close the bracket. Positions are defined in pixels from the upper left corner of the screen. As a second argument, we write a string between quotes to define the text that is displayed on the button. Label it switch material. Close the brackets and end with a semicolon. Test the script by saving and running the scene in Unity. If you didn't write any mistakes, you should see a button displayed above the game view. GUI elements are only visible when running a game. Now press the button. Nothing happens, as there is no reaction written for the button pressed yet. Stop the game and go back to monodevelop. If you press a button, the method will return a true Boolean value. So we can now add an if control method around the GUI button statement and react on the button being pressed. Simply copy the 2 lines of code that we put underneath the update method and paste them in the if statement. Now save and test your script. You can still use the M shortcut, but now you can also press the button labeled Switch Material. In this video lesson, we added an on-screen button to our script using the GUI class in the onGUI method. Buttons and other interface elements are good, as they don't require a manual and work equally on all platforms. In the next section, we will take our scripting efforts a step further. Take it or leave it, but in most interactive projects, a certain level of scripting is required to get any results. But rest assured that we'll take easy, small steps that are still very relevant to apply in other projects.